Hi, I'm Helen Osmond. I'm the founder of Osmond Education, and I've been a maths tutor since 2010. I have a Facebook group called Get Your Child Ready for GCSE Maths, where I give tips, tricks, and strategies to parents to help support their child in their GCSE journey. Now, in that group, one of the parents has put this question that their child needed some support with. This is an AQA question from the higher tier, paper 3 in June 2022. It was question 18 if you want to go and have a look. It's a circle theorems question. Now, a lot of students struggle with circle theorems because there are a lot of them. We generally only get the one question, and they can seem a bit strange and unrelated. Yes, there is an element of just learning them and practicing these over and over again. You could use flashcards to do either side. Put the rule on one side, put the picture or a description on the other so that you can memorize them. I'm going to show you my thinking for one approach to this question. There are 3 available in the mark scheme, but this is just the one that I would have gone through. So the first thing that I'm going to say is I'm going to read the question. A, B, and C are points on a circle with centre O. So A, B, and C are on the outside of the circle, and O is the centre. I also know that DC is a tangent to the circle, and that gives me the first rule, the first circle theorem that I should be watching out for. That tangents meet radiuses at 90 degrees, at right angles. So my alarm bells are already going with that word. As soon as I see tangent, I'm going to be prepared to use tangents meet radiuses at 90 degrees. The question is also asking me to show a ratio. I've got to show that angle ABO to angle ACO is in the ratio 3:1. So these are the 2 angles that I want to calculate in the question. ACO, which is this one, A to C to O in here, and ABO, A to B to O, which is in this one here. So these are the 2 that I've got to work out. So that gives me somewhere to start. Now, I've already said tangent in the question gives me the clue that I need tangents meeting radiuses at 90 degrees. Now, that makes this whole angle in here 90 degrees because O to C is a radius. Now, if the whole thing is 90, then I can work out the tiny little bit in here, which I'm looking for, A to C to O, has got to be 7 degrees because I'm going to take away the 83 from the 90 and I get 7 degrees. That tells me that ACO is 7 degrees. I'm going to write it on the diagram as well so it can be seen. Now, that's your first mark. Writing down the 90 minus the 83 or writing down the 7 degrees gets you the first mark. Now, the second mark is from this one. This is what I can see as I look at the diagram. I've got what's called the arrow, known as the arrowhead. Because if I draw it in like this, I've got an arrowhead. Now, the formal language for that one is that the angle subtended at the centre, and subtended just means made. The angle subtended at the centre is double the angle subtended at the circumference. So the angle made at the circumference here is 28. So the angle made at the centre here is 56. 2 lots of 28. So there we go. I've got another angle in there. That's my second mark if I take this method. Now, the next one I'm going for is I can already sort of see I've got a quadrilateral in here. 1, 2, 3, 4 sides. So it's going to be really helpful for me using this method to work out what this part of the angle is. I know that this inner part here is 56, and angles all the way around a point add up to 360. So I'm going to do 360 minus the 56. That tells me that this angle inside here is 304 degrees. Okay. Now, finally, I've already mentioned it, angles in a quadrilateral, so that's 1, 2, 3, 4 sides, they also add up to 360 degrees. Think like a square or a rectangle. we've got 360 degrees. So I can work out what this last missing angle here is by doing that subtraction. 360, take away the 304, take away the 7, and take away the 28 degrees. And that will tell me what I've got left in this corner. This here then is 21 degrees. You can check that in a calculator. It is a calculator paper 3, so that's okay. So there we go. Now I've got the two angles that I want. I want angle ABO. I've just worked that out here. That's 21 degrees, angle ABO. So that's 21. And my angle ACO was in the blue, is 7. Now that doesn't quite look like 3 to 1, but this is a ratio question. We can cancel ratios down just like we can cancel fractions down. We do it by dividing both sides by the same amount. If I divide both sides by 7, I get 3 to 1, which is what the question is asking me to do. But even if you can't complete this question, it's really important to note that you can get a lot of the marks as you go through. This is your first mark here, getting that 7. Your second mark using this method is getting the 56. Your third mark is getting the 304. Your fourth mark for getting the 21, and your final and fifth mark for getting 3 to 1 by cancelling down the ratio. So even if you can't do the whole question, try and work out any angle you can on there using the methods that you know, and that'll help you get some of the marks on this question. I hope that's a helpful going through of this particular question. And if you would like to join the Facebook group for any other tips and tricks, then please, the link will be in the description below, and you are more than welcome to come and join us. I'll see you next time.